Okay, this video is to discuss continuous probabilities under the standard normal curve and the normally distributed curve. Okay, so that correlates with sections 8.3 and 8.4. So I'm in Rguroo first because I want to pull up that calculator so it's ready to go. If we come over here to probability simulation, drop down the probability menu, and select the probability calculator that says continuous. We're going to be staying in here for all of 8.3 and 8.4. It's really important in these two sections to pay attention to what the mode in the calculator that the problem is asking us for, okay? So if the problem is asking us to find a value, then we want to make sure the arrow is pointing to values because that tells us that this gray box is going to spit out values. And if the problem is asking us to find the area under the curve, or also known as the probability for the continuous probability, we want the the arrow pointed to probability. So here is a practice problem in 8.3. First three words tells us what mode to put our calculator in. It says find the value. So I find that, especially when students are just learning these two sections, that the biggest mistake that they can make is forgetting to change the mode in the calculator and then confused on why the answer is not coming out correct. So I highly recommend that once you look at the question, it says find the value or find the area, that you select the correct mode in the calculator prior to reading the rest of the problem. So I'm going to come over here to Rguroo and I'm going to select the arrow pointing to the values mode. Okay, then it asks us to find the value of z such that a 0.13 of the area lies to the left of that particular value z. Now recall, a z comes from the standard normal curve where the mean is always 0 and the standard deviation is always 1. We talked about these characteristics in the standard normal curve in 8.2, and we also saw all the way back in 4.3 when we first introduced some DZ scores and the normally distributed curve with the empirical rule. Now, deciding how to translate what left looks like, I am in Blackboard in this week's content folder. You'll see that we have the inequality translation document that translates at most, at least, and what does that mean, less than, more than. And here I've added a chart to help you with our Rguroo translations from the drop-down menu. So when we see to the right, we'll be selecting above or upper tail. It depends on whether we're finding a value or finding an area. To the left, we'll be selecting either below or lower tail. If we are given an area in between, in the middle, then we'll be selecting between, and area that's given in the tails, specifically in both tails, not just one, it will be an outside problem. So for this particular one, they gave us 0.13 and they said it's to the left. So in that translation, that does translate to below or lower tail. And that lower tail, the area was 0.13. Recall that all areas and or probabilities, they're synonymous, are between 0 and 1, where all of our probability distributions add up to 1, making the total area under the curve a 1. Okay, so notice that the distribution chosen is normal. We don't actually have to change that distribution for these two sections. That's going to stay on the normal distribution. The default is the standard normal curve where the mean is always 0 and the standard deviation is always 1. So at this point, I've filled in everything I needed and I clicked my eyeball to get my z-score. So the z-score that marks the lower tail of 0.13 is negative 1.13. Z-scores are always rounded to 2 decimal places. So I will type that in here, negative 1.13, and it tells me, yay, I'm correct. All right, let's try another one. So here it's asking me to find a z-score such that 0.06 is the area that lies to the right of this z-score. So again, Let's first select our mode. It tells us to find the value. Okay, I make sure my mode of my calculator is pointing to values. Then I'm going to look at where is the area. It says to the right. If I come back to my chart, if I'm given area to the right, I need to select either above or upper tail, depending on what mode my calculator is in. So I'm going to select upper tail. Again, this is working with z-scores, so that implies the standard normal curve, and we keep the default of 0 and 1 for the mean and standard deviation respectively. And I'm going to type the area in that right tail to be 0.06. When I click my eyeball, I am then given the z-score that marks the right tail with an area of 0.06. Rounding to 2 decimal places, I am going to enter 1.55. All right. Next one. First 3 words, find the area. Remember, area is synonymous for probability. So I am going to come over here and change the mode in my calculator to pointing to probability. So I'm going to find the area under the standard normal curve. Okay, so that implies that I am working with a mean of 0 and a standard deviation of 1. I'm looking at to the right of a z-score of negative 1.48. To the right translates to above. I'm going to type in negative 1.48. And when I hit my eyeball, I see that there is 0.9306. We're going to round to 4 decimal places of the area lies to the right of a negative 1.48 z-score. Or if we translate that into percentages, about 93% of the curve's area is to the right of the z-score. Okay, so I would type in 0.93, I already forgot, 06 as my area to the right. Okay, let me find one that is a little different. How about this one? Find the value. I'm going to pause right there and change my mode in the calculator to make sure the area, so the arrow is pointing to the value. Find the value of z such that this given area lies between negative z and z. Now let's talk about what they're implying here, because there is something that they're implying when they tell you that it lies between a negative z and a z. When we're talking about between area, it is possible that that area could be anywhere in the curve between 2 z-scores. But when we reference negative z and z, that implies that the actual value of z is the same number, just a negative version of that number and a positive version. And the only time that that happens is when the area is centered in the middle of the curve. So what we know is this is a centered area of 0.9282, and it lies between a negative and a positive z-score. Recall that the curve is symmetric, and if our center is always at 0, then you're going to have mirrored positive and negative numbers on either side of our curve. So in our Rguroo, again, I am finding a value given a probability. I have my normal curve selected. I am still working in the z curve, or the standard normal curve, so I have a mean of 0 and a standard deviation of 1. This time they gave me an area between the tails. But what they asked me to enter is not the area between. So what the heck do I have to put in these boxes? Well, let me tell you why they do not give you the option to just type the area between. And the reason is because there's no way for our Rguroo to know that that area is centered in the middle. It may be skewed to the left or to the right, and we have plenty of problems where our middle area will be skewed, our between area, excuse me, will be skewed to the left or the right. And therefore, we have to be able to know to put in the areas that are in the tails, because that tells our Rguroo where exactly this between area exists. Is it centered? Is it skewed to the left or skewed to the right? So we have to do a little bit of math in order for us to be able to find out how much of the area is in the left tail and how much is in the right tail. So let me open up the calculator so I can talk you through the math in doing this. I'm just opening up the Desmos calculator that's right inside of Rguroo. Let me just see what that area was in the middle. So our area in the middle is 0.9282. Okay. So recall that the total area under the curve is 1 because all probability distributions add to 1. So if I take 1, the total area under the curve, and I subtract what I know is in the middle, 9282, then it tells me that there is 0.0718 left in both tails. That is the total of what's left. That is not in the middle. Now, how do I know how much of that 0.0718 is in the left tail and exactly how much of that 0.0718 is in the right tail? Well, that comes from knowing that the curve is exactly symmetric, which means that exactly half of this remaining area is in the left and the other half is in the right. So we will take 0.0718 and we will divide that by 2, giving us our area that is in the left, and it's equal in the right because again, our area is centered. So I'm going to copy that number. I'm going to click my tab to get back to my calculator. And that's the area that I'm going to say is in the left tail as well as the right tail, leaving exactly my 0.9282 in the center. And then when I hit my eyeball, I see that the z-scores that border this middle 92.82% or 0.9282 probability is a negative 1.80. Again, z-scores are rounded to 2 decimal places, and a positive 1.80. When we put this into Hawks, however, because Hawks knows that they are the same number, just one negative and one positive, you only need to enter the positive version of the z-score. Awesome. Okay, let's head over to 8.4. The difference between 8.3 and 8.4 is 8.4 are application problems. We are no longer in the standard normal curve. We are going to be in the normally distributed curve that correlates to an x value with units. So let me scroll down to 8.4, dive into this practice, and let's do a couple of these problems. So the time spent waiting in line is approximately normally distributed. For this particular section, you might not find that to be abnormal to see this because every single problem in 8.4 is going to be normally distributed because we're working with the normally distributed curve. However, as we progress through the rest of the semester, this is not always going to be given as an assumption, and that does change the way that we solve the problem, and that starts in chapter 9. So you're going to want to pay attention to these words. The fact that they told us that the data set is normally distributed tells us that the shape of the curve is a bell-shaped curve, and every bell-shaped curve is symmetric, and we know the mean is centered in the middle of that curve. Okay, so now we have a mean of 7 minutes. That is going to be our center versus the standard normal curve had a center of 0. Our center is now at 7. So if I come over here, you know what? I can't come over here yet because I haven't read the question and I don't know what mode to put my calculator in. The variance is given at 9. We'll have to talk about how to translate that because variance is not what we need. What we need is standard deviation. Okay, here we go. Find the probability. Remember, probability and area are synonymous words, but what this does is tells us what mode to put our calculator in, and that's what we should always do first. So in Rguroo, I am going to select the arrow pointing to probability mode. I know I'm in the normally distributed curve because it told me they were normally distributed. My mean was 7 minutes, so I do have to change the mean this time. I'm no longer in the standard curve. I'm not talking about z-scores with no units. I'm talking about x values with the unit of minutes. Now this needs the standard deviation, but variance is not the standard deviation. So recall that variance is just one step away from standard deviation. If you recall the symbol is sigma squared for variance versus standard deviation is sigma. And in algebra, how do we get rid of a square on a variable? We square root it. So given that our variance is the value of 9, if I come over to my Desmos calculator, what I'd want to do is take the square root of 9 to get my standard deviation of 3. Okay, so when you are given variance, be very careful. The wording is tricky. Square root that number to get the standard deviation of 3. Okay, let's continue reading. It wants us to find the probability that a person will wait more than 3 minutes. So again, if you need help with translating the English into inequalities, that inequality chart is posted in Blackboard. More than is to the right of the curve of 3 minutes. So we are going to be selecting above 3 minutes, and we hit our eyeball to get our answer that is 0.9088 if we were rounding to 4 decimal places. If we were going to translate what we found, it would state that the probability that any randomly selected wait time would be more than 3 minutes is a 90.88% chance. Right, let's try another one. Okay, the weights of a certain machine components are normally distributed. Again, that tells me what the shape of the curve is. It's bell-shaped, it's symmetric, and the mean would be in the center. The mean is 6.88. This time they gave me the standard deviation of 0.06. Find the two weights. Okay, so notice it doesn't say find the values. And that's because we're not working in the standard normal curve anymore, where Z represents a value and it doesn't have a unit. We're talking about actual application data sets. And in this data set, we're talking about weights of a certain machine component. So find two weights is another way of asking us to find the value. So before I do anything else, let's select the proper mode in our calculator. I need to find the two weights that separate the top 9% and the bottom 9%. Okay, so let's type in our mean. Let me write this down. We have a mean of 6.88 and a standard deviation of 0.06. Let's get those into the boxes. Okay, 6.88 and 0.06. It wants me to find the values, the weights that marks a top 9% and a bottom 9%. So that means I am given the area and the outside tails. So I select outside and I am going to type in 9% in the bottom. Notice that 9% needs to be translated into a decimal because all areas are between 0 and 1, and 9% in the top. And when I hit my eyeball, it tells me that that would be a weight of 6.8. And if I was rounding to 1 decimal, 7, I don't know how many decimals it wanted. Let's see. 100th place, which is 2 decimal places. So I would be typing in 6.8 because it rounds to 6.8 when I round to 2 decimal places. We'll put a 0 there just for ha-has. And this one would be 6.96 as my upper limit. Did I say 6.98? I already forgot. 6.96. There we go. Glad I checked. Yay. Okay, let me look for another one. Specifically, the grades one is pretty tricky. So let me see if I can find the grades one. Oh, let's try this again. Where are my grades? Okay, how is it that this problem is not coming up, but it came up every other time that I was working in here? Here we go. Okay, so this is one of the problems that I find trip up some students, so I wanted to make sure we go over this. Actually, this one's talking about a grade of an A. I really wanted to do the one, here we go. This is better, a grade of a D because there's an upper and lower limit on this one. All right, so we have an English professor that assigns grades on a test according to the following scheme. Now, this scheme is saying that instead of the normal grading scale, which is a 93 or higher is an A, and between like an 80, between an 83 and an 86 is typically a B, and so on. What it's saying is, doesn't matter what the students get, whoever is in the top 15% of what the students get in this particular exam are going to get an A. So that top 15% might be a typical students who are getting a C or the best grades in the class, then they automatically get an A. Let's see what kind of grades mark the limits for a D. So we know that the scores are normally distributed. Okay, again, that tells us bell-shaped curve, mean centered in the middle, and it's symmetric. The average grade on the exam was a 74.2, and the standard deviation is a 9.6. They want us to find the numerical limits. Okay, that's another way of asking us to find the values. So I double check my mode is at the correct one. I'm going to enter in 74.2 and my standard deviation of 9.6. Let's enter those values. 74.2, 9.6. They want me to find the numerical limits for a grade of a D. So I take a look. Here is the numerical, this is the area under the curve that correspond to a grade of a D. Be very careful to read this one carefully. The top 81% is to the right of the curve, and the bottom 6% is to the left. So these are written in the opposite order that we're actually going to be entering them into our Rguroo. But notice that they are giving me areas in the tails or the outside tails. So it's going to be outside tails where the bottom area, I already forgot, is 6%. Recall, we have to enter that in decimal form. And the top area, which is the upper tail, is going to be 0.81. So be very careful that you put the correct areas in the right tails. It does make a difference. And when I select my eyeball, it says that a student who gets a 59 through a 66, when I round to a whole number, will get a D on the exam. Okay, hopefully this video you find to be helpful when entering continuous probabilities or finding values under the continuous curve in our Rguroo.